In this video, we will compare Apache Spark and Hadoop MapReduce, two popular frameworks for big data processing. We will discuss their performance and usability, and help you understand when to use each one. On the left, we have the Spark logo represented by the letter S, and on the right, the Hadoop MapReduce logo represented by the letter H. In the center, we have verses written. Let's start with Apache Spark. It is a unified analytics engine designed for large-scale data processing. Spark offers built-in modules for various tasks, including streaming, SQL, machine learning, and graph processing. One key feature of Spark is its in-memory processing capability. This means it processes data in RAM, which allows for faster computations, particularly for iterative algorithms. Also, Spark provides APIs in multiple languages such as Java, Scala, Python, R, and SQL, catering to diverse development needs. Now let's discuss Hadoop MapReduce. It is a programming model and software framework used for processing large datasets across distributed computing clusters. One of the main characteristics of MapReduce is its disk-based processing. It reads and writes data to disk between the map and reduce phases, ensuring reliability. MapReduce is designed for large-scale batch data processing with built-in fault tolerance. Let's compare the performance of Spark and MapReduce. Apache Spark is much faster for iterative algorithms due to its in-memory processing. It reduces disk input-output overhead by caching data in memory. Hadoop MapReduce, on the other hand, uses disk-based processing between each stage, which leads to higher latency because of the frequent disk writes. Here is a comparison of the processing flow for Spark, which uses in-memory processing, and Hadoop MapReduce, which uses disk-based processing. For Spark, data is first loaded to RAM. Then, multiple operations happen in memory, and after that the results are persisted to disk. Hadoop MapReduce does not have the concept of memory persistence. It has a map phase where it reads and writes to disk, then there is shuffle and sort again with disk input-output, and finally a reduce phase with disk input-output. Now let's talk about the usability of Spark and MapReduce. Apache Spark supports multiple APIs including Python, Scala, Java, R, and SQL. It also has built-in libraries for SQL, machine learning, graph processing, and streaming. Additionally, Spark offers an interactive shell for real-time data exploration. Hadoop MapReduce is primarily Java-centric, with limited language options. It requires more boilerplate code, and is designed only for batch processing, lacking real-time processing capabilities. Let's compare the code required for both the frameworks. The task is to count words in a text file. On the left, we have Spark code written in Python, which is concise. We import Spark context, create a Spark context object, read the text file, flat map each line, map each word to 1 and reduce by key to get the word count. Finally, we save the output to a text file. On the right, we have MapReduce code written in Java, which requires mapper, reducer, and driver classes. The given code snippet shows the mapper class, which requires tokenizing and emitting the words. Additionally, we need to write reducer and driver code, which adds up to over 100 lines of code. So, when should you use Spark and when should you use MapReduce? Use Spark when speed is critical, when you're working with iterative algorithms, when you need real-time analytics for machine learning workflows, and for interactive data exploration. Use MapReduce when you are dealing with very large datasets, when you need high fault tolerance for simple batch processing, when you have budget constraints, and if you already have an existing Hadoop ecosystem. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.